Alright, we're on 7.3. Constructing triangles. And this, I think, is one of the really cool things that we can do. So if you look on page 85, it talks about different types of angles and sides. So part A on page 85, part A talks about the two angles and an included side. So two angles and an included side. So it's got 80 degrees as one measure, 30 degrees as another, and then it says 4.3 centimeters. I didn't measure that, it's not exact, it's probably not actually 4.3 centimeters. Actually, it's pretty close. Now look at that, I drew it freehand too. So 80 degrees, 30 degrees, and 4.3 centimeters. So it says that you can construct the triangle if you're just given those three things. So you can have, if I tell you two angles and an included side, included means like, hey, it's part of the party, it's included inside the other two angles, then you can draw that triangle. Every single triangle with 80 degrees, 30 degrees, and a 4.3 centimeters in between it, it's gonna look the exact same. So you can always draw it that way. B says two sides, and then instead of an included angle, this time you have an included, instead of included side, you have an included angle. So you would draw the angle, alright, let's say that that's 50 degrees, and then they tell you, hey, this is 2.5 centimeters and 4 centimeters. And you draw this 2.5 centimeters out, this 4 centimeters out, it's probably actually closer to that. And whatever it is, you can make your mark there, make your mark there, and then draw your straight line in between it. Again, as long as you have, this is 2.5 centimeters, this is 4 centimeters, and that you probably did the 50-degree angle first, all of those triangles are gonna look the same no matter what. So that's basically what we're talking about when we say included angles. I think that's all of it. So let's flip over to page 86 now. Page 86 says in triangle ABC, AB is 7 centimeters, BC is 2 centimeters, AC is 6 centimeters. Use a compass and a ruler to construct triangle ABC. So I'm going to start with the same one in the bottom that they have there. If they're telling you this is 7, 6, and 2 centimeters, I'm going to start off with 7 centimeters, so 0 there, 7 there. So that's 7 centimeters. And if I want to make something that on the other side is 6 centimeters, I just take my compass and say, hey, I'm going to go out to 6 centimeters. So I take the tape off, go out to where it says, lines up with 6 centimeters. That's 5, that's 7. Whoops. It's important why the tape is there, otherwise that's going to move. And just make it big like that. So this one, I'm just going to label it as 6 centimeters. So if this one is 7 centimeters already, this one's 6 centimeters. The last one I look at, it says it needs to be 2 centimeters. So then I take this tape off again and move this down to 2 centimeters. Notice how I can use either this one or that one, doesn't matter which one I actually have to use. And now I use the other side, right here. And boom, that's where they line up, that's where we draw the line through. So we've constructed our 7 centimeter by 6 centimeter by 2 centimeter triangle. And that always works. I always just start off with, they don't always say, hey, this is the bottom one, but I think what I found to be the easiest is if you start with that bottom one, construct whatever that is, and then from there go and say, hey, this one's gonna be 6 centimeters, so I draw that, this one's gonna be 2 centimeters, I draw that. You can come back and look at this video later if you want as well, but it's always gonna be that simple. It's not, like, they're not trying to do something really tricky here with you.
Okay, I have a question.
Yeah.
So, when it's an isosceles triangle,
Mm-hmm.
two of them are the same, right?
Yep.
So, when you're doing that, can you, so what I did for, kind of started the assignment.
Yep.
And for number 3, page 92, number 3, I did,
You do the same thing. So if they tell you, well, number 3 is an equilateral triangle, not an isosceles triangle. You
or,
mean
I don't know,
equilateral?
I don't know which one it is.
Well,
Or no,
you said
okay,
number
so,
3?
so number 3, yeah, never mind, there's a different one where it was, number 6, I have a question
Well,
on too.
regardless of whatever it is, I mean, if I look at number 6, says you've got 2 of them as 4 and 1 of them is 5.
Yeah, that's one.
Then you
Okay.
draw one is 4, another one is 4, another one is 5.
Isn't-
It doesn't, the change
Is
doesn't
there
change.
another way to do it though? You can bisect the 5 centimeter line? And then just line it up on there and there? Same for isosceles and equilateral.
You're talking about number 6?
6 or 4.
So this
or
is
6 or
about
3.
finding the angle measure. Number 6 on the assignment is about finding the angle measure.
No, it's constructing it, isn't
No,
it?
it's not. It says in triangle XYZ, find the measure of angle XYZ, XZY. So you have to draw the triangle and then take your compass and figure out what what degrees or what the measurement is for that one.
Okay.
Okay, do you have other questions about the assignment? Can you wait until after I'm done teaching? Because maybe there's a reason I teach it and not have you start the assignment early. Alright, so page 87 now. And by the way, if you haven't already figured it out, this is a really good one to have lots of paper for because your triangles tend to be pretty big. So page 87 says you've got 8 centimeters, and then 40 degrees and 35 degrees. So that would be the included side one. So I'm going to start off again with the 8 centimeters. Go. Okay, that's your 8 centimeters, and then 40 degrees and 35. So I see 40 is about right there, and 35 is about right there. So at that point, you just take this, draw the line through, and then you hope that you draw far enough that it's going to get through to both of them. That's yours right there. So this was 40, this is 35, and this is 8 centimeters. And yeah, you want to put the other labels on there, X, Y, Z, but it's pretty simple. You just put this one on, find the angle measure, mark it out on each side, and then draw the line through both of these so that they hit up at wherever you have X. And then, let's see, I'm going to start top of page 88. If you want to do that other guided practice beforehand, pause the video and do that, you can. I think this is easy enough that you should just be able to watch while I'm do it yourself, and you should be good to go. So it says X, Y, Z, you've got 5 centimeters, 3.5 centimeters, and then 50 degrees. So I'm going to start off, I'll make this a little bit lower, 5 centimeters. So I can make my 5 centimeters here. Can I draw my other line yet? Can I draw the 3.5? If I draw this 3.5, can I guarantee that my other angle measure is going to be 50? No, you can't. So you got to draw your 50 degree angle first, which is about right there. And then for this, I can either draw this 3.5, or I could draw this out as far as I want and draw a 3.5 to go across. So I'm gonna start by just drawing this. If you look at, see what, yeah, they do it to measure the 3.5 out on it, so we'll do that too. Okay, I see that's about going right through there. There's my 3.5. So that's one. And then that tells me what it's gonna be at the end. So 5 centimeters, 3.5 centimeters, and then 50 degrees. Good to go. So you can do that same one. And then the last one, page 89. I'm sorry, page 89, not 89 centimeters. Says you've got 4.5 centimeters, 2.5 centimeters, and 25-degree angle. And it says this time it is a non-included angle. So for a non-included angle, actually I'm glad I didn't do that last one, because I would have looked different if I had done that last one differently. So 4 centimeters on the bottom. And then 2.5 centimeters. I'll just draw, I can draw either one, left or right. Which one do you want to do?
Left.
Left, okay. So my left one, I'm going to draw, oh, actually, well, okay, so if I'm gonna do my left angle here, so I still have to do the 25 degrees, so that's what I was asking. You wanna do the you wanna do 25 on the left-hand side?
Oh,
Okay.
yeah, sure.
Okay, so 25 is right there. So I gotta think to myself, hey, this is 25 degrees. This is 4.5 centimeters right here. I want this to be a non-included angle. So this cannot be the one that's gonna be my, this cannot be the one that's gonna be 2.5 centimeters, because I don't want, because otherwise that's an included angle. So I want this to be the one that's going the other way. So I'm just gonna draw this one, I'll draw it through. And then this one, I look and see where do I get it so that if I start off here, that it's gonna be 2.5 centimeters. And I see that 2.5 is like way over here, so what do I have to go back and do? Because if I go straight up and have this be a 90-degree angle, it's only gonna reach like 1 point, what is that, like 1.9? Oh no, it's like 1.6. I have to angle it further this way, but I don't have enough lines, so what do I have to go back and do?
You have to go back and make the line longer.
Yeah, I have to go back and make the line longer. Hopefully I can make it longer enough so that I can actually get to the 2.5.
Wait, wouldn't it just be smarter to... No, never mind. That would work.
Yeah, that's the only way to do it. So then I go and I put this at 2.5. Oh, I just messed it up again. You gotta be really careful when you're putting that tape on it, because I just shifted it over to be like 2.2 instead of 2.5. The other thing is you could draw this side as 2.5 first, and then draw the 25-degree angle. That works too, because
Wait, why do you
then
need
you'll
to-
just know how far to draw it.
Why do you need to, do
Do this?
Yeah.
Because that way you don't have, that way you know exactly where it intersects. Otherwise, it is a little bit more of, if you're just doing this and saying, hey, I'm finding, hey, this is 2.5, I draw it right there. You can do that. It's not gonna be quite as accurate as when you use the compass. A compass is a tool, I mean, it's actually one of the coolest tools out there, because it was invented, I think, thousands of years ago, actually. I don't know for sure, maybe it's not quite that old, but it's like way older, like it's over 1,000 years old, at least I know that. And the fact that they could draw perfect triangles all the way back then with simple tools like this, like now, to draw something, a quote unquote like perfect triangle or whatever, it's not that easy. So this other one's 2.5 centimeters. And that's how you draw that one. So you might wanna go back and relook at how I did some of these during your assignment, but I'm not gonna make you have to do any of the guided practice in class right now, cause I think most of them are pretty straightforward. But that's all I got. Can you pause the video?